This video is made to accompany the 6.3 additional practice, part of our problem set for properties of parallelograms. So let's look and see what we got here. For number one, they want us to find the lengths in the parallelogram. So basically, we just kind of need to solve this parallelogram. So in a parallelogram, opposite sides are congruent. So BC is going to be 16.4 and CD is going to be 13.9. So 13.9 and 16.4 because opposite sides are congruent. For number 3 and 4, opposite sides congruent. If we set 3x plus 5 equal to 4x and solve for x, we can get those sides congruent. Take 3x away from both sides, x is going to be 5. So if x is 5, then Jm is 4 times 5, which is 20. And KL is 15 plus 5, which is 20. So JK is 20. And then we need to find out what KL is. Set these two equal to each other. And y plus 3 has to equal 2y minus 1. Take 3 away from both sides, minus 4. Take 2y away from both sides, minus y equals minus 4. Y equals 4, which means that JK is going to be 7. And 8 take away 1 also gives us 7. So LM, so we want KL. KL is 20. And JK is actually 7 for that one. Okay, let's look at number 5. Change colors up here. So if opposite angles are congruent, we have a parallelogram, and also same side angles are going to be supplementary. So if this is 112, this opposite angle needs to be 112. And this angle needs to be supplementary. 180 take away 112 gives us 68 degrees. And opposite angles need to be congruent, 68 degrees. Or we can go same side interior supplementary. So angle W would have to be 112, and angle Z would have to be 68. These are degrees. For 7 and 8, set these equal to each other. Now, we got mixes of x's and y's here, so let's see what we can do. Totally here, A and B together are a same side interior pair. They need to be supplementary. So if I say 4y plus 2y has to equal 180, we get 6y's is 180, which means that y is 30. Now, if y is 30, B is 120, and A is going to be 60. Same side interior angles, C is going to be 60, so X is going to be 60. And 5 times, anyway, this is going to be 120. Now, if X is 60, 300 take away 180 does give us 120, and we do have opposite angles congruent. So angle A needs to be 60 degrees, and angle D needs to be 120 degrees. Let's look at 9 and 10. We want to find these lengths now. So let's see. So we have a parallelogram. This diagonal is 14. Since diagonals bisect, that also needs to be 14. This total length here is 20. Since diagonals bisect, each one, DH is going to be 10 and HF is going to be 10 because the diagonals need to bisect each other. Okay, so EG, which is this total length, is going to be twice 14, which is 28. And DH, which is half of DF, is going to be 10. Okay, for 11 and 12, the diagonals need to bisect each other. So let's see what we can do with this. Okay, so this one, we can't really set the y's equal to the x's since they're different, so we need to come up with some kind of a way of talking about x. So if I start with the PR side here, since these two diagonals need to bisect each other, 2y needs to equal x plus 9. So if I take 9 away from both sides, I got x equal to 2y minus 9. So here's a way we can talk about x as being the same thing as 2y minus 9. Now, since the QS side also has two segments that need to be congruent to each other because t needs to be the midpoint, we can set 2y, let me change colors. I'm going to set 2y plus 2 equal to 2x. But now x is the same thing as 2y minus 9. So I'm going to substitute 2y minus 9 in for the x part there. And we should be able to solve for a y that makes this work out. So on the right side, using distributive property, we have 4y minus 18 equals on the left 2y plus 2. Take 2 away from both sides, gives us a minus 20. Take 4y's away from both sides, we get a minus 2y. Divide by negative 2, y equals 10. Now if y equals 10, 2 times 10 take away 9 is going to be 11. X is equal to 11. So let's see if that works out. Now if x is 11, this gives us a 22. This gives us a 20. 2 times y gives us a 20. And 2 times y plus 2, 2 times 10 plus 2 gives us 22. So we can see that these numbers for x and y work out to give us diagonals that bisect each other. Okay, we want to prove that EFK is congruent to GHK. One thing that we did in looking at this, we have vertical angles congruent here. We're given that we have a parallelogram, so diagonals are going to bisect. So we can see that they're using side, side, side. So opposite sides of a parallelogram are congruent. That gives us one of the sides. The diagonals by EG is bisected by HF. So that gives us EK congruent to KG, which gives us another side. And HK is congruent to KF, which gives us another side. So we can see that we do have a side, side, side pattern we can use. So EF congruent to GH, that's definition of parallelogram. Opposite sides congruent. And diagonals bisect each other, so that gives us EK congruent to KG. And also HK congruent to KF. So I guess this is the two sides we need. This gives us the other side that we need. So therefore, these two triangles are congruent. EFK is congruent to GHK by side, side, side. Circuit number 14. Let's see. So this is built in the shape of a parallelogram. What's the length of the flight of stairs that runs from the ground to the rooftop? So he wants to find out this length here. So find out the length of this side of the parallelogram. So it's 22 up. So the altitude or the height of this parallelogram, the distance between the bases is 22. Here we have a right triangle. So this, since opposite sides are congruent, we can find the length of this side using the Pythagorean theorem. We have 22 squared plus 47 squared is equal to, and we'll call this S squared for the stairs, the length of the stairs squared. So the length of the stairs is going to be the square root of 22 squared plus 47 squared. Okay, so that comes out to be 2693, and we take the square root of 2693 and round it to one decimal, we get 51.9. So if this is in meters, so the approximate length of the stairs from the ground to the roof is about 52 meters, 51.9 meters.